Alright, I am Mark, and we're going to talk about something that's near and dear to my heart, the integration of game design and software development. Oftentimes, a designer will make something, and they'll ask a programmer to build it for them, and the programmer will have a number of different options on how to build it, particularly when it comes to the algorithms used, is what we're going to focus on today. And this was a very common occurrence in my development of Energia, and we're talking about one particular aspect of it that caught my attention. So, in the game, you have towers, and they shoot things, and they need energy to attack. And that's all nice and dandy. So the question is, that we're going to talk about, is whenever they attack, what generator do they pull energy from? So, the simple answer is write a breadth first search or depth first search and find some random generator. And this is what's important about it. To a programmer, this is just a graph problem. But to a game designer, it's a lot more important than that. It's more subtle. Because you can't just take some random one because then it looks wrong. I tested this. If you have your generator and it comes here, the energy pulls from one new generator every single time, then it looks kind of strange because it's just kind of sporadic. So it's really nice to have, whenever it pulls from the same generator over and over, because it just feels nicer. But then there's also the problem of which generator exactly does it pull from? Because if it just pulls from the closest generator, then you don't get these long lines that you get to see your energy flow. But if it pulls from the farthest generator, then it can kind of look ugly. It doesn't always work very well. Additionally, you could some more complexities having to do whenever you have multiple energy networks, which comes in later. And so this all comes together to make a much more complicated, considered algorithm than just normal breadth first, depth first search. And what I ended up doing in this case is randomly picking one, then sticking to it until that one either runs out of energy or dies or something. But I wanted to point this out as something to consider when you're designing algorithms, that it's more than just making it work; it's making it feel right.